Welcome, everyone. So my name is Heike Zatterstrom. I'm the CCO of Boson Energy. I usually say here that when I'm done with my presentation here, you will never look at waste the same again. I said that at a presentation in Poland a few weeks ago, and the feedback that I got from a VC was that I was arrogant. But there's no arrogance here. There's just this very strong belief in the role that waste can play in the energy system. So we have a few infrastructure problems on our hands. There's not a shadow of the power or the grid needed to charge EVs. And something tells me that if Traton, Volvo, and Daimler gets together to solve a problem, it is a big problem. Today, you cannot find connected power for high power charging. And we're looking at phenomenal growth going forward. So there's a problem to solve here. One of the problems is that we have grown up in a NIMBY fallacy world where all problems are solved somewhere else. And where our energy security is based on oil and gas, and all the wind and solar that we need can be built somewhere else, where the grid is there to give us all the power that we need, where waste is shipped far away to be recycled, and we're also told that we can burn waste, and that's perfectly fine for our health and environment and climate. What we are doing is that we're inviting you to an IMBY world in my backyard where we solve waste problems locally and produce energy locally, where recycling rates are close to 100%, where 1 ton of waste can take a bus 1,000 kilometers, and at the same time avoid 3 tons of CO2 emissions. Globally, this translates into 1 billion zero-emission cars, if you will. And 10% of global waste is enough to replace all fossil methanol that are currently produced. So doing that, we say that we make zero waste possible. We turn it into a local circular resource that reduces infrastructure stress and supports the climate mitigation. And we need to do this better, cleaner, and cheaper. Because we cannot kid ourselves. I mean, to decarbonize and electrify in a sustainable way at scale, we actually need to beat fossils on commercial terms, on energy, effect, and price at point of use. And that's what we have set out to do. How do we do that? So we use gasification. It's one of these promising technologies that have been around forever. A lot of incremental innovation that goes into that. To reach the stability and efficiency and environmental efficiency and cost that is necessary to actually make this a mainstream technology. And we talk about this as the Tesla moment, because we have to remember that we had electric cars for 100 years. They never worked, it was never profitable, but a lot of incremental innovation went into that. Batteries, drivetrains, a bit of climate panic. And Tesla also realized that building electric cars is not enough. We need to invest in infrastructure as well for the charging, and boom, we have electric cars. So that is where we feel that gasification is today. And that means a one-step process, no moving parts, zero ash residues, tolerate changing waste. And our standard unit takes 100 tons of waste, which is a size that is good for a distributed solution. We want to be close. We want to be in my backyard, or the figurative backyard. 100 tons is still not my backyard. I mean, it's 50 to 200,000 people, but still, it's a community within a reasonable distance. And that will give me 7 tons of hydrogen. I will capture 100 tons of CO2. 60% of that will be green. I will produce a bit of heat and 10 tons of glass slag, which is what is rest. So all the nasty stuff in the waste is locked in here, oxidized, just like in a drinking glass. The drinking glass is also toxic things that have been vitrified, high temperature, and are harmless. And this can be used as a filling material in construction. But we can't wait around for a hydrogen economy. It will come at some point, maybe, but the vehicles, the infrastructure is not here. The waste is here now, though, and we need to do something now. So we need to find markets to serve that are here now. And one of those is speed charging. So we can deploy this hydrogen as 140 megawatt hours of local DC-DC speed charging behind the meter, which makes us completely independent of any other infrastructure or deliver grid support. That's 35,000 liters of diesel replaced, 250 tons of CO2 avoided, and cheaper than diesel. As I have the CO2, if you know a bit of chemistry, if you want to make an e-fuel or methanol, you need not just the hydrogen, but the CO2 as well. And we have that. If you have wind, you don't have the CO2. You need to find it somewhere. And some more CO2 and the heat, if we go full circular now, can be deployed in a vertical farming facility that will basically provide not only energy security, but local food security as well. And independent of energy prices. I mean, you have noticed that food prices are going up. In the Netherlands, they were struggling. Well, everyone has been struggling with natural gas prices and things like that. And with the slag in a full circular mode, cell glass, which is a high performance construction material that can replace concrete in many applications. This is an insulation material. It's currently made with recycled glass that is melted using natural gas. So it has a carbon issue and an energy cost issue. So there's hardly any of this produced in Europe because of that. And we can make this with waste. So 1 ton of waste is 1 cubic meter of cell glass. You can send this around. It's kind of interesting. The roof of the European Court of Justice in Luxembourg is insulated with cell glass from recycled glass, but still. So what is this incremental innovation? So we brought this technology to TRL 7.8, running on real waste, producing the syngas, the core technology. It has a big and slow bed. If you know gasification a little bit, you know the challenges. It has a big and slow bed for waste quality variations. It integrates pyrolysis, gasification. It has a plasma-driven heat production and vitrification and low capex and opex. And you can see on the right here, you have the yield. We have chosen to go with electricity to do the vitrification and the heat provision. As a result of that, we're not sacrificing carbon content in the waste to produce the heat that is needed for the process. So that gives us a parasitic load, but it gives us a high hydrogen yield. So we can either produce that electricity ourselves from the hydrogen, or we can take it from the grid if it is available. And we can take it from the grid when the grid is happy with someone taking power from them, and we can store it and then use it in our process. So in that way, we can support infrastructure doubly. We have brought this from science to fully integrated systems, together with some of the best companies in the world. All downstream systems here, because we produce our reactor produces the syngas, then you do a steam reforming and a water gas shift. And ultimately, a PSA will separate the gases. And all these are TRL9 existing technologies. And here we work with partners to put that in place. And that basically gives us unlimited capacity to scale from day one. We're also not manufacturing our reactor ourselves. And what is one of the main characteristics of waste then? It's the fact that, as I said yesterday, it's the most democratic and fair source of energy around. Not everyone has wind, sun, water for hydro, oil and gas, but waste, everyone has waste. And these are, I plotted here the incineration plants along this hydrogen valley. This is the same, regardless of whichever hydrogen valley you're looking at in Europe. You have waste in large amounts available. So what that means is that we can deploy these standard units in and around cities to produce this 140 megawatt hour and then distribute it to spokes around the city. It could be 20 megawatt hours. And if you run a bus company, or you will know that that is a major amount of energy that is deployed without grid. So what about incineration then? No, it's not an answer. We talk about incineration as the fax machine of waste management. It was great when it came. It had a lot of benefits, but I don't have a fax on my desk today. I don't know if any of you have a fax on your desk. It has poor energy efficiency. It's not hydrogen capable. It's a forced base load, emits the CO2. You can put carbon capture in theory, but in Oslo, they just shut down the project that they were doing there. And if Norway is shutting down a project because it's too expensive, then you know that it's not going to work anywhere else. Ash residues, water footprint, we actually produce water. If we're running this on parasitic load, if we're running parasitic on our own fuel cell, we will produce net water, which is unique in hydrogen context. Electrolysis needs water, big issue in India and other places as well. And just to give you an understanding for the difference in efficiency here, if I burn this waste at the bottom and produce electricity, I can drive 500 kilometers if I run it in power only mode. If I add CCS, I'm down to 350. If I make hydrogen from it, I'm down to 160 kilometers. Now, if we make hydrogen and put it into a fuel cell vehicle, you can go 660 kilometers. The interesting thing here is that if we go BEV, if we go speed charging instead, a stationary fuel cell can accept a lower quality of hydrogen, which has benefits for our system. We don't have to do as many passes. So we have a higher yield of hydrogen, which means that the BEV bus can actually drive further than the fuel cell bus. So is there a business model here? Yes. And we firmly believe that only profitable business is sustainable business. So there needs to be a business model. And what we have here is a situation where we have multiple revenue sources. We have a gate fee. We have the slag or the cell glass. We have the CEO ETS, if that comes around in a serious way. We also have CO2 sales. Tim here yesterday talked about CO2 as well. There's actually a scarcity of CO2 for industrial applications, for slaughterhouses, for cooling, for food and beverages. So ironically, we're fighting CO2 tooth and nail. At the same time, there is a lack of CO2. And then we have the charging, or we can sell hydrogen, etc. So that actually makes it possible for us to multiply profits in the value chain up to 20 times compared to incineration. So there is a business. And what happens here, and that is also why this is democratic and fair, is because incineration doesn't work in developing countries. If you make 15 to 20 euros per ton of waste in a profit, and you take away 80 euros worth of gate fee, the business case is gone. If we make 150 to 200 euros of profit per ton of waste in the value chain, you can take the gate fee away. It's not going to be as profitable, but it works. And green hydrogen, looking at a cost comparison, green hydrogen today, you're looking at 250 to 6 euros per kilo. That will go down, but you will always need to add getting this hydrogen to the local point of use, be that from the North Sea, Morocco, Australia, and that puts stress on the price at point of use. And that is the price that is interesting, because that determines the total cost of operation or ownership. We are at 2 euros today, but we are close. We're already around at the local point of use. Now, with these additional revenues, if we can do our business development well, we can get down to a zero cost of hydrogen. It's not going to be sold for zero, but it has effect. It affects the business model. So we have 2 billion tons of waste globally. That is 200 million tons of hydrogen potential. Global wind in 2021 had 31 million tons of hydrogen potential. And looking at the pace that we are building wind out, there will be fierce competition for that energy. In Europe, the offshore wind that is built out every year can supply 10% of the BEV additions in a year. So every year we say we have coming out, the offshore wind that we build will power one of them. And we're only at the start of BEV build out. And there's not a shadow of the infrastructure necessary to get this power there as well. If I take 10%, as I mentioned, global methanol, green, another 10%, global urea, decarbonized, I would need 120% of global wind to do this. So we have the potential here. Yeah, this is not a vendor presentation, but I just figured I would share a bit who we are. So we started with this, or our co-founder, Professor Blasiak, started researching gasification of solid fuels to extract hydrogen and biomass in the mid-80s. And he's basically had this IMBY vision then. Our founder, Jan Grimbrandt, came from other clean tech, including NOx emission reduction through primary methods on Polish coal plants, which was large scale. When Professor Blasiak came with his IMBY vision, Jan had just been at Drax, looking at the facility and see if they could do some work there. And he felt this IMBY vision was completely nuts. But Professor Blasiak was persistent. And in 2008, they founded Boson. Nobody was interested in hydrogen at the time, so we quickly had to pivot towards CHP, combined heat and power, and burn this beautiful syngas that we produce. But since a few years, hydrogen is back. We could use the COVID lockdown to dust off the business model. And here we are. Our CTO, Lirandor, has been many years in the business. He has built and operated one of the few plants in the world that has worked and operates on this. And our chairman, Bengt Andersson, an investor, was basically born into recycling and sold the family business to Veolia a few years ago to become Veolia Sweden. Our target is 1 million tons of circular hydrogen by 2030. I guess that depends a bit on Frans Timmermans and crew, if they are able to come up with positions and views on this. If they don't, they don't. We will just develop elsewhere in the world. But there are also a lot of pragmatic businesses. I mean, we have a problem to solve here, and waste is one of the things that can solve this. And we're looking at major volume potentials. We have a project pipeline. One of the interesting projects we're developing right now is a port in Sweden, which will probably be the first carbon negative port in the world. We will produce hydrogen that will be used for hydrogen powered speed charging, port electrification. One of the problems they have is that more and more vehicles are electric. You cannot ship charged battery electric vehicles, so they come to port empty. And he calls up the local DSO, the power company, and says, hey guys, I need another 20-25 gigawatt hours of power every year. And the DSO said, that's so funny. I don't have it. So you're on your own, basically. So what we're doing is we're bringing waste in, we're producing that power. The rest of the hydrogen we will produce methanol with, and the CO2, produce methanol. We will store away the fossil CO2. We will deliver heat to a local greenhouse and eventually produce cell glass. Very nice setup. We're also talking to, I think we're talking to 5 incinerators in Sweden that are very interested in a technology shift. They are understanding now. They sat down with Excel and they looked at carbon capture and they realized this is not going to happen. We actually need to make the shift. The other thing that is very important with incineration here, or the energy system in general, is that incineration is forced baseload. If you have a state-of-the-art coal power plant, it has been developed to go up and down. The power company can call you and say, hey guys, this weekend we don't need you, and you can shut down the power plant. You leave the coal in the yard, you come back on Monday and you start working again. That doesn't work with incineration because the waste comes all the time and you have to keep the temperatures up. So when you have to curtail, you have to pay to operate because you need to cool away all the heat that you would otherwise use to produce electricity. And I think on Ireland now, they have 1,000 hours per year that they cannot produce. They have no idea where this will go. They think it can go to 2,000 or 3,000 hours out of 8,000. And if you're today making 10 or 15, 20 euros per ton, if you take 30% of the power revenue away, it's going to hurt. The advantage here is that we are small scale. So at 100 tons per day, we can go in and replace line by line an incineration operation, because in a normal incinerator, which is larger scale, your lines will have different ages, different needs for refurbishment, etc. So there is an opportunity to do this without too much write-offs and capital destruction. And we can take the fly ash. The fly ash from the incinerator can go into this. And we have some other projects. We're the first, and I still think only, solid waste treatment technology that has been approved by the Clean Ganges initiative. So we're looking at a few projects in India, and we have a strong presence in Poland and Israel as well. So this is sector coupling that can change forever. Now I come to the arrogant part. The way that we look at waste, decarbonization, and electrification globally. We're looking at 20 million tons of hydrogen potential in the EU alone, globally 200 million. And yeah, thank you. I don't know how I'm doing on time here.
Thank you, Heike. No,
Is
you're
there
good.
time?
Yeah, there's some little bit of time if you want to.
Okay.
Yeah.
I have some backup slides if nobody has any questions. So I'm
I'm
good.
sure there will be. There's
You
a
don't
question
have to ask me questions. I can continue talking.
Let's start in the first row.
That's very impressive. So thank you for this. You addressed already the problem with regulations. Of course, it's clear that you needs to define that your hydrogen is defined green and so on. But I have one question. If you cannot directly use the CO2,
Yeah.
you cannot release it. Basically, what is underway? Do you need to liquefy and transport? Because I can imagine that not always the CO2 can locally be used. And it's quite a substantial quantity, though. Is it right to assume that then you need for the quantity, it doesn't justify a pipeline, then you need to liquefy it and transport it wherever it is.
Yeah.
Can be used.
So we have in the business case, there is room to take cost for this. I mean, the ports are very interesting from that perspective. The ports are interesting in many ways. We can also bring in waste, and we can bring all outputs, including the CO2, out through ports. It will depend on the situation. I mean, liquefaction is there. It's available as a technology. We have talked to a few of the major gas companies. I have yet to talk to Tim in more detail, but and we have been told basically that we will buy every single kilo of CO2 that you produce, pretty much regardless of where you do it. And that's once again, the waste and the energy need is where there is people. Where there is people, there's food industry, there's soda, there's beer, like the important stuff in life. So yeah, I mean, at the end of the day, the alternative is to put it on landfill. In situations I can see where there's no CO2 demand, you're probably in a situation where the waste will otherwise go to landfill. So if that would then be emitted, which we will strive to avoid, you still have a benefit compared to the methane landfill. And we have a lot of faith in all the efforts that are put into developing all kinds of very cool applications, fixed use applications. And that's our for CO2. And that's our preference, of course. I mean, storing things, it's just cost. There's nothing. If we can put this to use in construction materials and other things, then that's the optimal, of course. That makes it really circular. So yeah.
Yeah, short question here. Also, very impressive. Thank you. And I understand the little darts you're throwing towards EU, because all the quotas we saw yesterday, they are based on RFNBOs.
Yeah.
And currently, waste is considered biological origin. So
it is biological.
Yeah. so two questions. How do you evaluate the chances that hydrogen from waste will be considered green? Second would be, knowing that it currently is not considered as green, you're targeting more projects in the US, or is Europe still a target market for you, or is it already that you're saying, okay, let's focus on somewhere else?
Yeah. There's a company in the space that have a tagline that greener than green hydrogen. I like white hydrogen for waste. Someone else in the industry talk about white hydrogen, which is nice. It's clean. That's what we do. Yeah, this whole like, if our hydrogen doesn't qualify as green, the thing is we're carbon negative. Nobody else can do that. I mean, you're still looking at green hydrogen from direct from wind, ignoring all the challenges of intermittency and all that stuff. You're still at, I don't know, 0.6 kilos per kilo of hydrogen emitted. So it will reduce emissions as opposed to if you use that hydrogen to replace other things, but it's not going to go negative. It's not going to compensate for other things. So we're talking to a major shipping company that is looking for green hydrogen. They say the fossil part we will not touch. We will need assurance that that is kind of not going into the methanol that you will produce for us, which is no problem. And they are completely confident. I mean, they have more resources, of course, to put the finger on the pulse in Brussels and things like that, but they are completely confident that this will be resolved. We are on the CEO roundtable of the European Clean Hydrogen Alliance. Unfortunately, there's most of the discussions there are around electrolysis. We're a few companies that come from a hydrocarbon angle there. The Commission in the chat on the side in these calls, we get a lot of support from the people working in the Commission, and they believe in this. We have in the project, we have 10 projects that were included in the European Clean Hydrogen Alliance pipeline, which is basically the European Commission's hydrogen pipeline. And they have been vetted for sustainability, feasibility, carbon performance, and so we see that as a vote of confidence. Basically, that okay, the regulation is not really there at this place, but we are confident that this is important. And yeah, yes, we have a lot of discussions in the US as well. I think we have in the last year, we have talked to the PE owners of about 30 million tons of incineration capacity that are very curious about this. And I guess as a PE owner, the fact that you can make 150 to 200 euros per ton treated as opposed to 15 to 20 is appealing. Plus the fact that you are not emitting 30 million tons of CO2 at the same time. Yeah.
There's a question here in the fourth row.
Great presentation. Thanks, Heike. Question I have is on scale. What is the largest gasifier you have today, and how big can you go? Are there any constraints on scale?
So the setup today, or the setup is the reactor is 2 tons per hour. There's a smaller reactor, 1 ton per hour for medical waste, hazardous waste, toxic waste, things like that. But the standard reactor is 2 tons. We will set this up in a setup with 3 reactors. That's the standard module, is 3 reactors, and then you say like, hey, the math doesn't work here because you only need 2 reactors to get to 100 tons per day. But we have the 3rd reactor to create redundancy because we have to be our own backup. Looking at the volumes that we can produce in a location, in an urban location, there's no backup. We cannot go out and ask the next electrolyzer guy next door and say, hey, we have maintenance, or we have this, or we have that. Can we get hydrogen from you? They cannot produce those volumes. So that's how we set that up. And the port project here is, and that translates into then 36,500 tons per year. The port unit or the plant that we're setting up is 220,000 tons. So we're basically putting 6 units. And we don't really see the need to scale to a larger reactors. Sure, there are many things, but that also kind of auto creates a lot of redundancy in the system. And we don't see necessarily in a port, yes, you go to that size, but we don't necessarily see that that's not our ideal setup in a city or similar. because we really want to get this in my backyard, to treat your own waste, not other people's waste. And then that's what we're going for.
Yeah, good morning. Do you see waste has got competing claims today?
I'm sorry?
I said waste has got competing claims for different technologies.
Yeah.
Whether it is biogas, whether it is SAF, whether it is 2G, or for that matter, many other technologies have come up. Even.
Yeah.
So your model would be more of a decentralized hydrogen production only? Or
Yeah.
do you think it will be scale?
Let's see if I had that. I was looking at that slide if I was going to bring that in, the comparison between different technologies. I didn't. I'm sorry. Yeah. If
So once you set up and you've got competing waste claims, the pricing of waste goes up. We've already started seeing that. So do you think your model will be only decentralized so that you don't have to run around for waste? You take the localized waste and just...
we ourselves will not run around for waste. So we focus on what we do, just as we work with partners for all the downstream processes. We will work with partners for the upstream. So we're not going to run around and bid for waste and things like that. We will set up where there is a waste source and a partner that has a relevant volume. So in terms of other technologies, yes, there are no silver bullets. And what we are doing, our ambition is to do the rest, the stuff that nobody else can do. So if I have a crop residue without contamination, etc., then by all means, biogas or pyrolysis. There are some plastic streams. If I can take a plastic stream out of an industrial value chain that is pure and you know what it is, then by all means do pyrolysis any day of the week. But the second this waste has touched the consumer, you have contaminations, you have things that makes pyrolysis complicated. You can still do pyrolysis, but it's not an end to waste because you will have a residue you will deal with. You all have, what we have developed our technology, it's a very slow process, which makes a minimum requirement on shredding. You have faster gasification processes that require a lot of sorting, a lot of shredding, down to 2 by 2 centimeters, because the waste goes through the process very quickly. We have 20 by 20 centimeters because the waste will spend 8 to 10 hours in our reactor. So there is time to complete all these processes. And that's one of the things that we do, is because waste does change. If you develop a technology that requires waste to be in a certain way, you have a problem. So we in this development, we're accepting the fact that waste is what it is, and we're developing our technology to adapt to that. We cannot adapt waste to our technology. We have to do the other way around. So so that's how we think, and that gives us a lot of benefits for taking care of the non-recyclable stuff. I mean, you have these processes that have a 7-step sorting unit before. I mean, we will do automatic sorting for metals and aluminum and things like that, of course. And our preference is anyway to work with post-recycling waste. I mean, recycling tops out at 50 to 60% recycling rates, also in the most advanced recycling economies in the world. And it is still questionable whether the refuse is actually deducted from that or what the real recycling rates are. So we see ourselves as the technology that can bring that up to 100%. Yeah. What was the one thing? Yeah, and in terms of the availability and waste, I mean, here I plotted incineration plants in Germany over population centers. So you basically as an indicator, so you can see like, yeah, the waste is really where the people are. And technology-wise, we have gone through, I think, 4 generations. Let's see which one this is here. Yeah, you didn't see this. Yeah, so here as I said, plotted the incineration plants over population centers in Germany. So you can see that there is a lot of potential here. Yeah, this is our vision to build 1,000 fast chargers in Europe. The waste is there. It will create a major infrastructure relief and possibility to do these things, to roll out commercial vehicles, heavy duty vehicles. Because today, in the contracts, in the tenders that the municipalities issue for buying electric buses, for instance, talking to the OEMs, they tell us that there's always a clause in the tender that says that if we as a municipality is not able in the end to come up with the charging for these buses, you will have to commit to deliver diesel buses for us. So you can ask yourself how this EV rollout is actually going. I mean, these tenders, these contracts are signed, and I guess these buses are made to be delivered in 2-3 years. So I guess the verdict is out. How many of these vehicles will actually be electric? Because in general, in grids today, the grid that you have coming into a bus depot, is typically okay to electrify 2 or 3 buses. But if there's 200 buses in the depot, what do you do? We can ship in 20 megawatt hours of charging on a truck once a day, and you're done, you're set. It can be used whenever you want it. The sun is not really shining at night when the buses are standing in the depot, so charging that with sun is going to be tricky. Wind is also tricky. So yeah, so that's the situation there.
Thank you, Heike. Any other questions? One more here.
It's so nice to have time. I've been on this like 4-minute pitches, 3-minute pitches, and it's just nice to be able to have a conversation with you guys. There was someone here.
Yeah.
There as well. Okay.
So Anna Krüger from Heuer Group, logistics company. So I'm interested in, by the way, I can confirm the availability of charging stations, charging infrastructure for trucks is really a problem in Germany. By the way, one statement on mobility. Currently, transport of hydrogen is not possible with hydrogen fuel vehicles, as we are still waiting for the ADR homologation in Europe, but that's just on the side. You made a statement that this is cheaper than diesel. Mm-hmm. Can you elaborate that statement? So what is behind?
Yeah, I mean, it's math. I mean, if I produce the diesel parity today, if you're at €1.50 per liter, you're at 8 euros per kilo of hydrogen. If you kind of translate the distances, etc. €2, you're at 10. We produce hydrogen at €2. We sell it to the HRS at, let's say, at 5. I mean, there's still a lot of room there. And the same, you can translate this into electricity prices as well.
You did not take into account the capex of the investment of a hydrogen powered truck versus
Yes, that has effect on that as well. Yeah, and I mean things need to happen, I think, on the capex there as well. But on the BEV side, I mean, it's fairly comfortable. If you translate this into electricity prices, I think the diesel parity is about 40 cents and per kilowatt, and we can get below that. So yeah.
One last question in the front, and then we'll continue.
You had one too, or
The microphone's coming.
So yeah, Lucas from Heike Instrumentation. Thanks for this great presentation. Well, you explained gasification has been around for several years. So what have been now the biggest challenges for Boson to develop to come to where you are right now with the gasifier process?
Technology-wise or just in general?
Technology-wise, right.
Technology-wise, we have eaten a lot of refractory. We work with RHI Magnesita on the refractory. It's an extremely corrosive environment inside this, so there was a lot of work went into burning through refractory and coming up with compositions, etc. Then you have the fluid dynamics, you have all these things. I think but it's just work. I think it's as we have developed to really treat these to kind of adapt the technologies to the waste, we had to, because in many situations or in many technology, you need to spend a lot of work on the pre-treatment and how to get that right and things like that, and make sure that it's mixed and homogeneous and all those things. Those issues we don't have. Tar cracking, always an issue with gasification. Since we have a slow pyrolysis stage first, and then the gasification. The pyrolysis takes care of the volatiles, and then the gasification goes into the fixed carbon. As a result, we have a slightly higher volume of tars than is achievable, but the advantage is that our tars are less complex, which makes the tar cracking easier. And that's how that's how because there's no magic in this. It's making decisions. What are the trade-offs that I'm willing to accept to build a system that will support the business model that I want to roll out. So, and there you have to navigate the different choices that you have in gasification, and just develop a technology that supports your business case. And also think about the scale from the beginning, because there are some players in the space that then developed a technology that was at the scale where they then afterwards realized that, okay, we're actually getting killed by our overheads here, because you're at a scale where the overhead per kilo treated is too high. And then there are others who went ginormous. There's a big failed project in Teesside in the UK where they went from lab scale to, 1,000 tons per day, a completely ridiculous scale up, and it failed miserably. So being patient, scaling up, we've scaled this up carefully in different scales here, starting out very small lab scale and then kind of going step by step. There are a lot of things stability, repeatability, availability, designing the plasma torches to reduce maintenance, etc., and getting the whole kind of system to work together. Yeah.
Thank you.